Right, that looks beautiful, Derek. Just take a big breath, all right?
Yep. And can you see the laser too?
Yes, we can. We can see everything. That looks
Perfect.
great. All right, take a big breath. All right. So our first presentation will be from Dr. Derrick Vaughn, and he's from our Earth, Ocean, and Atmospheric Science Department, brand new building. And he's going to be speaking today on fingerprinting human impacts on streams.
Okay, thanks, Debbie. Okay, so currently on our planet, we have over 7.8 billion people, and that number is continuing to grow. And because we have so many people, we've already seen that over 50% of Earth's land surface has already been altered. And a lot of that has been related to a loss of wetlands and forests to replace that land with areas dominated by agriculture and urban cities. And here in the United States, in this top figure, we've seen an overall increase in agriculture going from 1850, as indicated by the blue colors, where there's relatively low amounts of agriculture, to 2000, indicated by the red, where there's been relatively higher increases in agricultural areas. This bottom figure here shows that overall in the United States, we've seen an overall increase in the amount of urban area. And so combined, replacing forests and wetlands with agriculture and urban areas are potentially influencing the local ecosystems in these areas. And this also includes the streams and rivers that run through these land covers. And so by changing these areas into agriculture and urban areas, you're potentially introducing pollution by introducing nutrients and toxins that may be harmful for the ecosystem. By clearing out the forest, you're introducing potentially a lot of sediment to the rivers, and using structures like dams to modify the flow or get impact the ecosystems downstream. Now, rivers are also very important for the global carbon cycle. And this figure here may seem a little complicated, but it's actually pretty simple. So overall, rivers, they take the carbon from the land that surrounds them, and they can either drain that carbon to the oceans, or they can release that carbon back to the atmosphere as carbon dioxide. However, if you change any of these components, such as changing the land cover from a forest to wetland to agriculture and urban, you could be changing how that carbon is cycled. So here at Florida State, we're analyzing that carbon in rivers in different ways. A common method is looking at the total amount of dissolved organic carbon. And so whenever I say organic carbon, I'm referring to carbon that's mostly being produced in nature and living organisms. And then whenever I say dissolved, I'm referring to carbon that passes through a filter, sort of like what you see with your coffee. Now, one thing that's unique about Florida State is that we have the mag lab available with some very advanced instrumentation so that we can fingerprint dissolved organic matter. And when I say organic matter, again, I'm kind of referring to carbon-based compounds being produced in nature. And when I say fingerprinting, I'm looking at the molecules within that organic matter and looking at what elements are common in those molecules, including carbon, hydrogen, nitrogen, oxygen, and sulfur. And so in this study, we're looking at the Mississippi River, which flows through 10 different states. And we're mostly focused on the upper Mississippi in both Minnesota and Wisconsin. We had 9 total streams that we studied. 3 streams were in urban areas, indicated by the gray, 3 in agriculture areas in the orange, and then 3 in forest and wetland areas in the green. And overall, we found that the forest and wetland areas had the highest amount of organic carbon in the rivers. And we related this to there being more vegetation at the surface that surrounds the rivers. And that higher amount of vegetation can contribute more organic matter to the soil. Whereas agriculture and urban areas, those areas are often more disturbed because you're developing on them. And so you're losing that organic rich surface soil, which explains why they're lower. Now, when we're looking at the land covers and the organic matter, we found there are 24,000 different kinds of formulas or unique or combinations of those elements. And of those 24,000, 15 were unique to agriculture, and all 15 of those had nitrogen, which could be related to fertilizer use and production of manure, whereas the urban only had one unique formula, and that contained sulfur, and that may be related to discharge of wastewater. And so the overall findings were that we did find unique fingerprints for agriculture and urban land covers, which can be important for looking at how these may impact carbon cycling further downstream. And then land cover changes overall along these rivers are altering how the carbon is cycled. So thank you for that.